Hello ladies and gentlemen, and welcome back. In this video we're going to continue looking at the 2013 Open Contest, and we're going to finish off Part A, the easier 4 questions, with question number 4. So A4 is the subject of our attention now. A positive integer is said to be bidigital if it uses 2 different digits with each digit used exactly twice. For example, 1331 is bidigital. So would 1133, because then, 2 1s, 2 3s, they're both being used. Whereas 1113 isn't, because it's got 2 digits, but they're not both used twice. 1111 isn't, because it's only got 1 digit. 1333, again, you've got 2 digits, but they're not used twice. And 303, now why would they think to mention this? Well, they're sort of highlighting the fact that leading zeros aren't counted as part of a number. So if you write it like this, you might fool yourself into thinking, well, it's 2 digits and they're each used twice, but leading zeros don't count. And this can often be a hiccup for questions like this. Now, what do we want? Determine the exact value of the integer b, an odd way to phrase that, the number of bidigital positive integers. So we just want to know how many bidigital positive integers there are. Okay. So we're going to have to pay special attention to this leading zero stuff. Okay, so if a digit is 0, what could my 4-digit number look like? And it's always going to be 4 digits because we have 2 different digits and they're each used twice. So it's a 4-digit number. Now we can't have a 0 anywhere up front. So either we have a 0 here and then maybe another 0 here. And then my other digit, let's call it A. Incidentally, we have 9 choices for our other digit A, 1, 2, 3, 4, 5, 6, 7, 8, 9, and any of them are allowed to be up front. So we always have A up front because you can't put the 0 up front. You can't have a leading 0. And so then we've got 3 other options. The real question is, where do you put the other A? So 3 choices for digit placement. So 9 times 3, 27 bidigital numbers. But that's if you've got a 0. Now suppose we don't have a 0. Okay? If we don't have a 0, then we have to make choices for our digits A and B, and we don't know which is which, so what I'm going to do is I'm going to say A is the smaller one. That way my choices are unique. Okay? So how many choices are there for an A and a B like this? Well, for example, if A is 1, B could be 2, 3, 4, 5, 6, 7, 8, 9. Those are the only options for B. How many of them are there? There's 8. If A is 2, how many choices for B are there? Well, B could be 3. It can't be 2, it can't be 1. It's got to be bigger than A. 4, 5, 6, 7, 8, 9. And so there's 8 choices, 7 choices. And we can go all the way down. A being 8, you're sort of forced with B being 9. So you'll have 1 choice. And so you'll have 8, 7, 6, 5, all the way down to 2 and 1. Now if A were 9, well, B has to be a digit that's bigger than 9, and there's no such thing. So how many choices is this? Well, 1 plus 2 plus 3 plus 4. So you might know this number. It's going to be 36. It's not that hard to work it out on your own. But 36 choices for digits. And that's a lot more than just the 9 we had before. Okay? So 36 possible choices, and then what we have to do is we have to choose how these digits are arranged. And so there's going to be, should be 6 ways to do that. We'll write them out and explain that in just a moment. But you'll notice, how are we counting? Well, we're splitting up into cases where things needed to be treated differently. So 0 is can't have a leading 0, so that's got to be treated separately. And then we're breaking it down to, okay, how would I make a bidigital number? Well, I'd choose my digits, and then I would choose how they're arranged. And you don't have to do it in that order. You could choose how the digits are arranged, and then choose what your specific digits are. But whenever you make a choice and then another choice, if you want the total possible combinations, you multiply the numbers. That's why we're figuring out, okay, there's 36 ways to make this choice, and then, or times, however many ways to make the next choice. But the next choice is, how do I arrange my digits? Okay, so let's get into that. So how do we arrange the digits? You can just sort of list out the possibilities. Remember, it doesn't matter which ones first, because none of these are problems in terms of leading ones, or sorry, leading zeros. Okay. And I'm not being as careful as I probably could be. BBAA, that's the last one. Okay. For a longer list, you'd probably want to be very methodical, very organized as to how you write these things out. But you're going to find that there's only 6 possibilities. Now, if back in this stage we didn't care which digit was bigger, we could actually get twice as many choices, because you wouldn't necessarily have A being the lower one. But you have to be careful that you're not double counting. So here I'm allowing all possibilities. So there has to be some difference between A and B, because if I were just allowed to pick any pair, you know, A, B is 2, 3, I could get 2, 3, 3, 2 as a possibility. Right? That would be the ABBA possibility here. But if I was also allowed to have 3, 2 as a possibility, okay, which we aren't this way we're counting, but if you were trying to count it a different way, then you'd get the same number, but with a different pattern here. So you have to be careful. And you have to be careful when you count so that you do not get any repeats. Okay? So there's 6 choices for digit placement, or digit pattern. Okay? You could say instead there are 72 choices for the pair AB. If you aren't going to order and necessarily say that one of them is smaller, but then you're only going to have 3 choices of pattern. Okay? So you would still get the same product. So this gives us 36 choices for AB times 6 choices for how to arrange them. That's 216. So in total, we get 216 plus the 27 if one of the digits is 0. 3, 1, 4, 243. Okay, so 243 is going to be our sum there. Okay, so 243 is the number of ways, and that's really all there is to say it. I would probably summarize it just because they specifically mentioned value B. B is 243. Okay, so let's turn the page to get ready for, I think that was our last, that was our last A part question. So up next will be the B part of the contest. That's the middle part of the contest. If you haven't given them a try, I would encourage you to do so. Remember, you can always get a copy of the contest clicking the very first link down below. Feel free to leave a like if you're liking the 2013 paper so far. Leave a comment if you have a different way to do a question on any video. If you ever see me and you think, gee, that was nice, but I had another way to do it, maybe a faster way to do it, or a different way of thinking about it. I always like reading different ways to do the contest. And if you want to be kept up to date as I post more of our 2013 Open or any of our contests, feel free to subscribe. But all of that's up to you. I will see you for B1 in the next video.